Good day everyone, and welcome to the fifth video in a series of videos illustrating the range of the tangent function. In this video, we will discuss the concept of periodicity as a property of any of the trigonometric functions. So what does it mean for the tangent function to be periodic? So let's discover, and what are the characteristics of the quadrants where the tangent function has equal values. And at this end of this video, students will be able to determine the reference angle and its corresponding angle, and students will appreciate the beauty of periodic functions in mathematics, fostering a positive attitude towards learning trigonometry. Let's first explore this GeoGebra build that I created and answer the following questions as we discover the definition of periodicity. Alright, so let's begin. First question. We're going to discover the tangent value of a reference angle. It will be an angle at the first quadrant. So if alpha is set to 30 degrees, what is the value of tangent 30 degrees? So in this applet, we just need to change alpha to 30. Alright, so tangent 30 degrees is around 0.57735 something. Okay, so the first option is positive 1 over square root of 3. So equals 1 over and then square root of 3. So 1 over square root of 3. Yeah, we got it right. Okay, so 0.57735. So this one is equivalent to 1 over square root of 3. Okay, very good. So here's our second question. This is for the angle of the third quadrant that is corresponding to the reference angle. So if the reference angle is 30 degrees, what is the measure of the corresponding angle in the third quadrant? What is the pair of 30 degrees? Okay, that would be in the third quadrant. So to determine that, everyone, we just need to add 180 degrees to the reference angle. So our reference angle is 30 degrees. So 30 degrees plus 180 degrees. So that would be 210 degrees. Okay, very good. Next question. The slider gamma is adjusted to 210 degrees. What is the relationship between tangent gamma and tangent alpha, which is 30 degrees? Okay, so we'll change the gamma to 210. What did you notice? Yes, they have the same tangent values. Okay, so what's the correct equation here? Or the correct inequality? Is it an inequality or equation? It's an equation. So we have observed that tangent alpha is equal to tangent gamma. Okay, next one. Now we're going to adjust the sliders to set alpha to 45 degrees and gamma to 225 degrees. Okay, so 45. And our gamma this time is 225. Alright, so tangent 45 degrees is around 1 and tangent 225 degrees is equal to 1. Okay, so the correct option. First option, no, alpha and gamma are unrelated. B, no, they are both in different quadrants and therefore have different signs. C, yes, they both have negative tangent values. Or D, yes, they are the same. And 45 degrees is the reference angle that corresponds to 225 degrees. So, the tangent value of tangent 45 and the tangent value of tangent 225 are equal. So they are the same, and yes, 45 degrees is the reference angle that corresponds to 225 degrees. Okay, next question. exploring tangent values of a reference angle in the second quadrant and its corresponding angle in the fourth quadrant. Okay, so our alpha this time is 120 and our gamma is 300. Okay, 120 Okay, so that will be the second quadrant. See, point C is at the second quadrant, and then 300. And 300 is at the fourth quadrant. But did you notice they have, both of them are negative values and the tangent values are equal, right? Okay, so what will be our correct answer here? Of course, option B. Tangent alpha is equal to tangent gamma. So as a conclusion, here's our final question. So investigating equal tangent values of reference angles and their corresponding angles. So which of the following pairings correctly represents the property of equal tangent values of reference angles and their corresponding angles in different quadrants? So we have two correct answers here. Option A, we are pairing first quadrant and second quadrant? No, because both of them are in the same period, right? At the upper semicircle. Option B, reference angle in the first quadrant and corresponding angle in the third quadrant. We're pairing first quadrant and third quadrant? That's correct. Option C, reference angle in the second quadrant and corresponding angle in the fourth quadrant. We're pairing an angle in the second quadrant with an angle in the fourth quadrant. That's correct. Okay, then option D, reference angle in the fourth quadrant and corresponding angle in the first quadrant. That is not correct. We cannot pair fourth quadrant angle with the first quadrant angle. So what are our discoveries? Alright, so the tangent values of the angles in the upper semicircle from 0 degree to 180 degrees are repeated as tangent values of the angles in the lower semicircle from 180 degrees to 360 degrees. So since tangent values repeat every after completing a semicircle, and since one semicircle completes a pi, then the tangent function is periodic with a period of pi radians or 180 degrees. This means that tangent x is equal to tangent x plus n pi for any integer n. The tangent value of a reference angle x is equal to the tangent value of that reference angle plus a multiple of pi, describing instances of one complete semicircle. We also discovered equal tangent values at the first quadrant and third quadrant angles, and in the second quadrant and fourth quadrant angles. Again, one period is pi radians, 180 degrees, corresponding to a semicircle. And the y values, or the tangent values of angles within one period, like 0 to 180 degrees, are the same as those in the next period, from 180 degrees to 360 degrees. Here are some examples. We have a pair of first quadrant and third quadrant angles. So tangent 5 degrees is equal to tangent 185 degrees. Tangent 12 degrees is equal to tangent 192 degrees. And then for the pairing second quadrant angles and fourth quadrant angles, so we have tangent 110 degrees is equal to tangent 290 degrees. And tangent 165 degrees of the second quadrant is equal to tangent 345 degrees of the fourth quadrant. And how did we get 185 degrees as a pair of 5 degrees here? Alright, so we just added 180 degrees. So 5 plus 180 degrees is 185 degrees. 12 plus 180 degrees is 192 degrees. 110 degrees plus 180 degrees is 290 degrees, and 165 degrees plus 180 degrees is 345 degrees. So let's enjoy again the GeoGebra canvas a while ago and observe that the same set of y values for an angle in the first or second quadrant with the third and fourth quadrant, which is part of the second period. So please do observe the similarity of the y values of point C2 and point C3. Enjoy! So I would like to thank Dr. Sirag, the author of the pre-calculus book that I reviewed, and of course to Mindshapers Company Incorporated for publishing such a book. And to all of you who are watching the video lessons and reading the teaching document, thank you so much. So again, this is Tutor Man. I hope that you have learned something.